Hi there, this is a lesson on dilations, and please note that you will need a straight edge in order to complete these notes. That is really important. It doesn't have to be a ruler, it could be anything with a straight edge, but make sure you have that before you begin. Alright, so the first part is talking about vocabulary, and we are talking about dilation. So a dilation is a transformation that possibly changes the size of a figure. The other transformations that we have studied have been rotations, reflections, and translations, and none of those changed the size of the figure, they just changed where the figure was. So this is the big difference between a dilation and the other three. A figure and its image under a dilation are similar figures, whereas the others were congruent. In similar figures, corresponding angles are congruent and the sides are proportional. This means that the angles are equal to each other, and the sides, you can multiply the smaller side by a number bigger than 1 and get the larger figure's same side, or you could take the larger figure's side and multiply it by a number between 0 and 1 and get the smaller corresponding side. So what we're talking about in that idea of multiplying is the scale factor. So in order to find the scale factor, this is extremely important, so make sure that you highlight this. The scale factor is the length of the side of the image divided by the length of its corresponding side of the pre-image. So you want to make sure that you understand that. We will go over how to find scale factors in just a moment. So you take the side length of the image divided by the corresponding length of the pre-image. So in part 2 we're going to find the scale factor. First we have to identify which of those is a dilation, and the second one is what is the scale factor. So in number 1 here, we can see that all we do is we slide a left 2 and down 1. So this would be a translation. So this one is out. Number 2, I can see that these do not have the same shape. Now, you might argue that they're both triangles. That's true, but it's distorted. So those are not dilations. So number 3 is a dilation. So we're going to circle that for the answer. And now our job is to find the scale factor. So I'm going to take the length of a side of the image. So the image is A prime B prime. And I'm just choosing that side at random. I could choose any side. Divided by the length of the side of the pre-image, which is side AB. So that will find the scale factor. So A prime B prime has a length of 3 units. 1, 2, 3. So that's 3. And AB has a length of 1. So the scale factor is 3 divided by 1, which is 3. Alright, let's move on to number 2. Find the scale factor of the following dilations. So we're going to take the length of a side of the image divided by the length of the side of the pre-image. You can choose any side to do this. I'm going to choose P prime S prime divided by PS. So P prime S prime is 1, 2, 3, 4, 5, 6 units long. And PS is 1, 2, 3 units long. 6 divided by 3 is 2. So my scale factor is 2. Now, Since the scale factor is greater than 1, this is called an enlargement. Let's move over to this other example with L, M, and P. So with this one, I'm going to choose one of the sides. So I'm going to do L prime, M prime, divided by L, M. So remember the image is the primes. So L prime, M prime is 1, 2, 3, 4 units. And LM is 1, 2, 3, 4, 5, 6, 7, 8 units. 4 divided by 8 is 1/2. So my scale factor is 1/2. Since this value is less than 1, this is called a reduction. So you can see that an enlargement makes the image bigger and a reduction makes the image smaller. It makes sense. All right, let's move on to part 3. Part 3 says to find the image of triangle ABC after a dilation of center 0, 0 and a scale factor of 3. And the vertices of ABC are A is 1, 2, so plot 1, 2. Negative 2, 1 is B. And negative 1 is C. Now use your straight edge to connect those points. Since the center is 0, 0, right here, what we do is we find out from 0, 0 how far away it is. And the easy way to do this is just, I'm going to say I went right 1 and up 2 to get to A. So my scale factor is 3, which means I multiply those by 3. So if I went right 1 and up 2, I multiply those by 3, I would go right 3 and up 6. So this up here, let me change colors here. So 3, 6 is A prime. So A, which was 1, 2, now goes to A prime, which is 3, 6. And that's because the center is 0, 0. Alright, so to find B prime, the coordinates of B were negative 2, 1. So what we're going to do is, since it's a scale factor of 3, I'm going to multiply both of those by 3, and I end up with B prime at negative 6, 3. So I plot negative 6, 3. And that's my B prime. For C, the coordinates were negative 1, negative 1. Multiply both of those by 3. I get negative 3 for C prime. So I plot those points, negative 3, and that's C prime. Please use your straight edge to connect those dots. So what we've done is we have enlarged triangle ABC, and each side of triangle ABC has become 3 times longer. It's hard to measure the distance without a ruler because it cuts through the grid, but I guarantee that those are 3 times larger. Now what I want to do is take a moment to show you what happened here. If I connect A and A prime with a line, and I will use a different color, so let's do purple. If I connect A and A prime, and B prime, and C prime. You should notice that all of those intersect at the origin, and that is because the center of dilation was the origin. So if my center of dilation is somewhere else, when I connect B prime, A prime, and C prime, those will intersect wherever the center of dilation is. All right, let's go ahead and move on to the next page. Here we have to find the image of triangle DEF after a dilation with center 0, 0 and a scale factor of 1/2. So right away I should realize that my new triangle is going to be smaller than my original triangle. So go ahead and plot D, E, and F. So you should end up with that triangle. Please make sure you're using your straight edge. Now, to find the coordinates of D prime, we take the points 4, 2, and we multiply each of them by 1/2. So half of 4 is 2, so D prime is 2, and half of 2 is 1, so it's 2, 1. So I'm going to plot 2, 1. And then E prime is going to be half of 0, which is 0, and half of 0, which is 0. So E prime does not move. And F prime is going to be half of 6, which is 3, and half of -4, which is -2. So 3, -2 is F prime. So let's go ahead and connect the dots there. And since the center of rotation was 0, 0, and E was on 0, 0, that's why it didn't change at all. And you can see that one triangle is completely inside the other one. And this is called a reduction since the new triangle is smaller than the original triangle. Okay, so let's take a look at part 4 here. Two figures are similar if one is the image under a dilation of the other. So we are going to be asking you to prove that they are similar, and so to prove it, you will have to show that one is a dilation of the other. Now, a fact is that two triangles are similar if at least, and that's an important phrase there, at least two of their angles are congruent. If two of their angles are congruent, then that will also result in their sides being proportional. So remember at the beginning of the lesson, two similar figures had congruent angles and all the sides are proportional. So those are the requirements. Now, something that you should already know is that the sum of the angles in a triangle is always 180 degrees. So that's something that you should have already known. So in this triangle here, we are given two angles and two sides, and we want to know which ones are similar down below. So the first thing I'm going to do is I'm going to find the missing angle right here. I'm going to use the fact that angles add to 180 inside of a triangle. So 80 plus 45 is 125. So we need to do 180 minus 125 to find that missing angle. Alright, so we get 55 for that. So this angle up here is 55 degrees. Now if you go back to the paragraph above, it says that if you have two angles that are congruent, then their sides will be proportional. So all I'm going to look for are two angles that match these three angles here. So 80 matches and 45 matches, which means that this triangle is similar. We're going to go to the explanation of proportionality in just a moment. In the little tiny triangle here, 80 and 45 match with 80 and 45, so that is similar. This one here, 55 and 45, if we had not done this work, we might say that those are not similar, but we did the work. This is 55 and 45, that matches 55 and 45, so this one's similar. Down at the bottom here, we have 60 and 25. Those do not match the angles, so that means that this triangle is not similar. And we can look at that and say that they're not similar because they have different shapes. And then the last one, we have 55 and 80. We have 55 and 80, so that one's similar. Now, that was enough to show similarity, but we are going to go ahead and understand the proportionality. So a proportion is a fraction equal to another fraction. So if you take a look at this big triangle right here, the side measure between the 80 and the 45 is 10 inches. You compare that to the side angle between the 80 and the 45 in the original. So the side measurement between 80 and 45 is 5 inches. So it's 10 to 5, and that should equal the other side that we're given. So the length between 45 and 55 here is 12, and the length between 45 and 55 up here is 6. So does 10 over 5 equal 12 over 6? They both simplify to 2, which means the sides are proportional. Now, to find the scale factor, you do the length of the image divided by the length of the pre-image. So that's what we did here. Length of the image was 10, length of the pre-image was 5, so the scale factor is 2. Okay, in this smaller one, the side length of the pre-image, the side length of the image between 80 and 45 is 2.5. And its corresponding side in the image, pre-image, was 5 between 80 and 45. So 2.5 divided by 5 is 0.5 or 1/2. So that is your scale factor. Alright, we are done with this lesson. Now you have to do the worksheet on dilations in class.